Keeping in mind the 4 programmer stereotypes, we have deep dived the concept of virtual environment, and I show you how we can create a virtual environment and how to operate inside it. Now I want to take a look also at the Git version control system, which is one of the most used free and open source version control systems in the market. So Git is a version control system, and in particular the Git data is presented as a collection of snapshots, in which each of these snapshots memorizes the state of the project, the entire project, and Git creates an image of all the current files in that instant. It's a snapshot of all your files and what is inside them. So Git does not work with differences between the previous versions and the version we are looking right now, but memorizes each progress. So takes snapshots through time. For example, here we have the two version control systems in comparison. So in the delta storage, so we work by differences. For example, the file A has been modified one time. So at the second step, C2, we record a difference. For example, one line has been changed. But in the same instant, the file B has not been changed. So no differences are stored and memorized. And we move on through time. In the snapshot version control system, in particular Git takes a snapshot of file A, B, C each time, even if for the file B nothing has been changed. So the Git system provides, yes, more redundancy, but is quite faster. Because if we are in C5 and we want to compare what's inside those 3 files with respect to the C1 stage, here we have to work to move back by differences. While in the snapshot version control system, we just take the C5 snapshot and the C1 and compare them. That's why Git is very fast, and also provides some mechanisms that reduce the redundancy. So in Git, there are 3 states that files can have: the committed state, the modified, and the staged. So we are in our working directory, and a stage file means that a current version of the file, of the modified file, has been marked to go into the next commit snapshot. So in the stage area, we have the files that we are interested to take snapshots of. The files that need to be tracked. In the modified state, instead, the file has been changed but has not been committed to the database yet. Finally, the committed state means that the data has been stored in a local database, so we have committed it into a repository, and we have took a snapshot of that file. These 3 states are bounded and linked together by these sections. A Git project has three sections: the Git directory, the working directory, and the staging area. Let's start from left to right. We have the working directory, in which we have our project directory, basically, that can contain 100 files. But we care about only 50 of them, and we want to control the version of only about that 50. So we move that 50 files to the staging area here. This means that as we work in here, files have been staged, and a file is in our Git directory. So this is the staging area. We can modify the file again and again and again. And then we commit that file, and we move it from the staging area to the Git directory, where the Git stores the project metadata and object database. Basically, it takes a snapshot. So Git takes a snapshot here, but we are moving from left to right. From the working directory, we select some files that we move inside the staging area. In the staging area, we have the files we care about and that we want to version. After modifying them, Git does not store every modification we do, but only when we tell it to take this snapshot. In order to do so, we have to commit that files, and through the commit, the Git will take the snapshot of the file and move it to the Git directory. For example, here we have 3 different commits. You can see the different features about every commitment, and usually it has a sort of ID that identifies each commit. In this way, you are able to go to move ahead or to move through the past using the names, the IDs of every commitment. And each commit is a snapshot. So the Git workflow works as follows. We are in our working directory with some files. We care about versioning some of them. We add them to the staging area. And once we have done with our, for example, coding, we commit that code into a committed region in which a snapshot of that file has been taken. But if we work with a central repository that could be in the cloud, we have to take another step, the push step. We push the snapshots, the commits that are in our local machine to the cloud. For example, GitHub works in this way. Locally, we create the files, we add them in the staging area, and we commit them, but we are still in our local machine. To move them to the cloud, we have to follow the step of pushing that files to the central repository, the GitHub repository. So right now we have completed a general overview about a Python project and how to set up it. But we are still missing one piece. How do I write Python and how to run it? And this is why we will talk about it in the Python tools and IDEs section.